And here's the last video that goes with today's lesson. All right, if I look at dividing this, I've got my negative 12 divided by positive 3, that would be negative 4. And then 48 divided by 6 will be 7. So we're going to have the square root of 7. Except I made a mistake. That should be 8, not 7. Oops. 42 is 6 times 7 is 42. 6 times 8 is 48. All right, now 8 can be broken down further. 8 is the same thing as 4 times 2. So I can change that into 4 times 2. And so the 4 will come out and become a 2, and I will have negative 4 times a 2, and then times the square root of 2. And then negative 4 times 2 is negative 8, and root 2 is multiplying it. Okay, part E, I'm looking at 8 divided by 2, and that gives me a 4. But if I try to do 75 divided by 48, it doesn't go nicely. So I do notice that 75 could be written in smaller terms. 75 could be a 25 times a 3. But while I'm at this, I'm going to actually do my 8 divided by 2. So that will become a 4. So I'm going to leave the 4 on the top. There will just be a 1 on the bottom with that. And 75 is the same thing as 25 times 3. And 48, I think we can break that one down as well. 48 is the same thing as 16 times 3. This is interesting. All right, 25 square rooted will give us a 5, so we're going to have 4 times 5 times the square root of 3. Notice I'm leaving a step out there. Square root of 16 will be a 4. 1 times 4 is 4, and I still have that multiplying a root 3. Now this is nice because a root 3 divided by root 3, they just cancel each other out. That'll just be a 1 overall. This 4 and this 4 will cancel each other out. I probably should have used a different color. So this 4 divided by this 4 will cancel each other out, and it's just going to leave us with a 5 here. Okay, so overall the final answer for that one will be 5, and the reason we can cancel these things out is that we're straight multiplying and dividing. There's no adding or subtracting, so that works out with that. All right, part F, if you want to give that one a whirl, see how you do, and put this on pause, and then you can press play. All right, 12 divided by 3 would be a 4 over 1, or just a 4 on the top. 96 I'm going to break down, because if I try to do 96 divided by 54, it's not going to go nicely. 96 I think is the product of 16 and 6. So I'm always looking for the biggest number. 4 will also work, but it's not going to give us the number in simplest form. Okay, and we want to go as simple as possible. And then 54, I think that's a 9 times a 6. And then the square root of 16, trying to get my stylus to work here, I've got 4, the square root of 16 would be a 4, and that's still multiplying a root of 6. And then on the bottom we have 1 times the square root of 3, or square root of 9, which is a 3, and then we've got square root of 6, and I can reduce some things here. The root 6 and the root 6, they can reduce each other, straight up multiplying and dividing. I can cancel. There's nothing else I can cancel there, so 4 times 4 on the top will be a 16, and 1 times 3 on the bottom will be 3. So that's equal to 16/3. All right, the last piece, which if you're going on in advanced functions next year, is a process called rationalizing the denominator. Sometimes answers will be expressed with a rational denominator. So rational numbers are numbers that can be expressed as fractions. They're your terminating decimals or your repeating decimals or your integers or your whole numbers. On the bottom of this first example, we have the square root of 7. If you do the square root of 7, it's a non-terminating, non-repeating decimal, which means it's an irrational denominator. So to rationalize the denominator, the process is pretty simple, straightforward. We multiply the top and bottom of the fraction by the radical part of the denominator. Okay, so we have a root 7 there. And I'm going to then multiply that entire fraction by root 7 over root 7. All right, let me grab my pen here. Maybe, there we go. Okay, so this fraction is going to get multiplied by root 7 over root 7. The reason I chose that is because the denominator, the radical part of the denominator, was the square root of 7. Multiplying by root 7 over root 7, this root 7 over root 7, that's really just equal to 1. So if I'm multiplying by one whole thing, it's not changing the value at all. So in doing so, multiply numerators together, you're going to get 2 roots of 7 on the top. On the bottom, you've got root 7 times root 7, which is the square root of 49, which is really just a 7. Square root of 49, you get 7. So now that denominator is a rational number. It can be written as a fraction of integers, like 14 divided by 2. Okay, so that's the process there. Try the next ones. See how you make out with that. Part D, I'm noticing the radical parts are big, so I'm thinking with part D, you want to break those down into simpler form and then rationalize your denominator. You can probably do some reducing there with that one. Okay, put the video on pause, give it a shot, see how you do, and then check. Okay, let's check your answers for B and C. Hopefully they make sense. For part D, I broke down 24 to be a 4 times 6 and the 54 to be a 9 times 6. That gives me 9 times 2 and a 12 times 3, and they're both times root 6. So those root 6s can reduce. I can reduce further here. 3 goes into itself once and goes into 9 3 times. I could take the 3 and the 12. 3 goes into itself once and into 12 4 times. Oh, and 4 is even. 4 can be divided by 2, and that gives me 2. 2 can be divided by 2, and it gives me a 1. So overall, on the top, that's going to equal a 1, and on the bottom, it's going to equal 2 times 1 times 1 is 2. So it reduces to 1/2. Hopefully that all makes sense. Make sure you're asking for help if need be, and there are questions to follow this in your duotang.